When the power is turned off, a fan disk inside a jet engine slows down with constant angular deceleration 0.8. Find the time taken for the angular speed to decrease from 950 to 750. First, I am going to talk about analogy between linear motion and circular motion. Time analog with time, displacement with angle, velocity with angular speed, acceleration with angular acceleration, and so on. And we can make formulas. If we know these formulas, then we make another formulas if we apply analogy. For example, A is equal to acceleration is equal to change in velocity over change in time. So this quantity is equal to change of velocity over change in time. Then angular acceleration is equal to change in angular speed over change in time, and so on. So we'll use these formulas. First, this formula. So angular deceleration, it's negative. Initial angular speed, final angular speed, and change in time is equal to change in angular speed over angular deceleration. After substitution, we get the time 250 seconds. There is a second solution. We can apply this formula and minus omega u over alpha, and after substitution we get the same solution. Find the angle through which the disk turns as the angular speed decreases from 220 to 200. We'll use this formula, but we need time, so before we use this formula. Let's see. So we have angular deceleration, initial angular speed, and final angular speed. We have to calculate theta. First, we'll calculate time as before. It's 25 seconds, and after we'll apply this formula. Angle is equal to average angular speed times time, and after substitution we get the solution. I suggest you a second solution. You can use this formula. Find the time taken for the disk to make the final 10 revolutions before coming to rest. So theta is equal to 10 times 2 times p. One revolution is 2 times p. We should reverse the time, So it's not deceleration, it's acceleration. So angular acceleration, not minus it, plus 0.8. Initial angular speed 0, and we need time. We can use this formula. From here we express t, multiply by 2, divide by alpha and square root. So this is t. After calculation it's 12.5 seconds. There is a second solution. If we don't reverse the time, so angular acceleration or deceleration minus 0.8, theta 20 times p, final angular speed 0, and we need time. First we use this formula and calculate initial angular speed minus this and square root, so it's 10 radians over second. And after this we can use this formula and change in time is equal to change in omega over alpha. Final angular speed minus initial angular speed over angular deceleration, and we get the same solution as before.